Hi, and welcome to this video on finding the exact value of tangent of alpha minus beta, where alpha and beta are angles we don't see explicitly, but more implicitly. So the first thing we can say is that alpha is in the first quadrant because alpha is between 0 and pi over 2. Alpha is in quadrant 1. And then we can also say that beta is in quadrant 4 because beta is between minus pi over 2 and 0. So beta is in quadrant 4. Graphically, we're thinking of the unit circle. We have our circle of radius 1 centered at the origin. Let's imagine that's the unit circle. And that's the unit circle. And then quadrant 1 and 4 are right there. And alpha is in quadrant 1 and beta is in quadrant 4 because quadrant 1 is composed of angles going between 0 and pi over 2. And quadrant 4 is composed of angles going from 3 pi over 2 to 2 pi. Or if we work with negative angles, we have minus pi over 2 to 0. Okay. And okay. So somewhere here we have alpha, and somewhere here we have beta. Because alpha is in quadrant 1, we can say that alpha is definitely the inverse sine of 7 over 25. That comes from applying inverse sine to both sides of the equation. So here is sine alpha equals 7 over 25. The inverse sine alpha is the inverse sine of 7 over 25. And because alpha is in quadrant 1, alpha is between 0 and pi over 2, we can say that alpha is the inverse sine of 7 over 25. Now B is in quadrant 4, and we have those bounds for B. Then when we apply the inverse cosine, both sides of the equation that says cosine of beta equals that number, we find the inverse cosine of the cosine of beta equals the inverse cosine of 8 root of 145 divided by 145. And if beta was between 0 and pi, we'll be able to say, okay, cosine, inverse cosine, and cosine just cancel one another. But because beta is not between 0 and pi, we say, well, because beta is in the fourth quadrant, we say, well, instead of working with this beta, we should work with the beta either in quadrant 1 or quadrant 2, where angles go from 0 to pi. And to get an equivalent angle, like an angle that has the same cosine as beta has, we need to go to the first quadrant. So if beta was this angle right over here, we will need to go to this angle right over there. That is a reflection of this angle with respect to the x-axis. So where we go with cosine -1 of cosine of negative beta equals cosine -1 of 8 root of 145 over 145. Because cosine is even, the cosine of beta is the same as the cosine of minus beta, and minus beta is between 0 and pi, because beta was between minus pi over 2 and 0. So when we change the sign of beta, then beta is actually in quadrant 1, not just between 0 and pi. So now we get to cancel this to get minus beta equals inverse cosine of 8 root of 145 over 145. So beta is negative inverse cosine of 8 root of 145 divided by 145. Okay. So far we have found alpha and beta more explicitly. I know that alpha and beta don't look very explicit, but they are as explicit as they can be. And we found alpha equals inverse sine of 7 over 25. And beta equals negative inverse cosine of 8 root of 145 over 145. The next thing we want to do is we want to find a tangent of alpha minus beta. And we're going to sub in what alpha is and beta is. So here we have the tangent of inverse sine of 7 over 25 minus negative inverse cosine of 8 root 145 over 145. And this is the same as tangent of inverse sine of 7 over 25. And then negative sine times negative sine gives us a positive inverse cosine of 8 root of 145. And then over 145. And here we're working with tangent of an angle plus another angle. We can use the sum formula for tangent to find tangent of inverse sine 7 over 25 plus tangent of the inverse cosine of 8 root of 145 over 145. All of this divided by 1 minus and then tangent of the inverse sine times tangent of the inverse cosine. It's taken really long to write all this. 8 root of 145 over 145. Okay. All that. And okay, so now we get to work with finding the exact value of a composition of expressions. We have tangent composed with inverse sine or tangent composed with inverse cosine. And work with that kind of composition, we work with triangles. That's one way to go. So now we have, okay, one triangle we want to work with is the triangle related to 7 over 25. Replace this 25 on the diagonal. The 25 is the length of the hypotenuse of this triangle. This is 7. Okay. And then there we have, if this is 25 and this is 7, then we can check that this is 25 squared minus 7 squared under the root. That gives us some exact number, but we're not going to worry about it. So that, and this is our angle alpha. Remember that alpha is in the first quadrant. So the tangent of alpha, that's inverse sine of 7/25, is positive. And based on this triangle, we can say that that tangent is equal to, we work with y over x, now we go with 7 over the root of 25 squared minus 7 squared. And of course we can simplify this, but we're not going to worry about that in this video because we're more focused on trigonometry. And then the next triangle has to do with the inverse cosine of 8 root of 145 over 145. So let's draw a triangle here. There we go. And that positive cosine, inverse cosine of this quantity is negative beta. Remember that we had to go with negative beta to use the inverse cosine function here. When we apply the inverse cosine function, we got to use the minus beta. And minus beta is in the first quadrant, then the tangent of cosine, the negative one of this is positive. And based on what we have here, we need a triangle that has a hypotenuse of length 145 and a side that is the one at the ground level would be 8 root of 145 units long. I'm going to drag this triangle to the left because we won't need to write a huge number here. Okay, and we complete the triangle. If we want to find a tangent of negative beta, that's what we're working on here. Remember, this is negative beta. This expression right here is negative beta, same with this one. And if we want to work with that triangle, we want to find tangent of that angle, then we want to work with this triangle. And to work with this triangle, we have this right triangle. One of the sides is 8 root of 145 units long. The hypotenuse is 145 units long, then this side has to be this side has to be the length of the hypotenuse squared minus the length of the side squared. All that under the root. Then the tangent of the inverse cosine of 8 root of 145 divided by 145 corresponds to y over x in this triangle. But remember that this tangent is positive, so I don't need to write a negative sign at this point. And then we have 8, so y over x, so that's this term, 8 root of 145 squared, all that under the root, can it fit? And then divided by x, so x value is 8, 1, and then square root of 145. Okay. Okay, now the next thing we would do is we would insert those numbers into the equation here. But I guess we can write that, but that's going to be really long. Okay, let's do it. So this is going to be 7 over root of 25 squared minus 7 squared added with root of 145 squared minus the square of 8 root of 145. All that under the root, and then divided by 8 root of 145, and then all this is divided by, wow, that was really straight. Then 1 minus 7 over 25 squared minus 7 squared. That kind of looks nice. Okay. It doesn't look as nice. I just rewrite that. 7 over okay, and then times the other root, the other things, which the other fraction which involves many roots. So there's 145 squared and then minus 8 square root of 145 squared and then under the root. Wow, that's really straight. Then 8 root of 145 as the denominator. Okay, and if you're taking a course with me, there's no need to go any further. If you're not taking any course with me, well, it depends on your prof or the textbook. You might have to get a number out of this. Okay, and I'll try to remember if I remember that number. I'll give you that number shortly, or maybe you figure it out. So yeah, but that's how we will go about solving this problem. We're going to find a tangent of alpha minus beta where alpha and beta are not exactly explicit, but we can find a formula for alpha and beta in the process, and then we apply the sum formula for tangent. Okay, I hope you enjoyed this video. If you have questions, let me know. I'm happy to help. Bye-bye.